Let's explore the journey of this M1A2 SEPv3. You've heard the legends, but you haven't seen the data.
Every bolt here serves a purpose. From the depleted uranium mesh to the Ethernet backbone, this is the...
We begin with the hull, the foundation of the SEPv3's increased weight management profile.
The electrical architecture is the first major upgrade. We've moved from layer to a high-capacity distribution.
This ensures the turret can handle the massive instantaneous draw of modern active protection systems and the high-speed Ethernet backplane.
The Honeywell AGT 1500 gas turbine, 1500 shaft horsepower. It's not just an engine, it's a jet.
We examined the pulse jet air filtration system. It uses reverse air blast to self-clean, keeping the turbine breathing even. The fuel delivery system manages JP8, diesel, or marine fuel with surgical precision.
The Allison X1100-3B transmission, managing 4 forward and 2 reverse speeds, essential for the shoot-and-scoot doctrine.
Thermal management is critical. These fans dissipate the massive heat signature generated by the turbine core to reduce IR detection.
This is the engineering pivot, the UAAPU. It allows silent watch capabilities.
The UAAPU reduces the thermal footprint by 70%, making the tank a cold target for overhead IR sensors during stationary operations.
Without the main engine idling, the tank is nearly invisible to long-range acoustic sensors and seismic detectors.
The fuel-to-power efficiency ratio is monitored in real time by the Vehicle Health Management System, predicting failures before they happen.
Maintenance accessibility has been improved, allowing for a full power pack, engine and transmission swap in under 60 minutes.
Let's look at the T158LL tracks. They utilize double-pin technology and replaceable rubber pads for reduced vibration.
Despite the 73.6-ton weight, the ground pressure is distributed to maintain mobility in soft soil conditions.
The suspension utilizes high-hardness steel torsion bars and rotary shock absorbers to stabilize the fire platform during cross-country movement.
These shocks are critical for the SEPv3's improved fire-on-the-move accuracy, absorbing 90% of vertical oscillation.
Each of the 14 road wheels is reinforced with heavy-duty bearings, specifically rated for the SEPv3's increased armor mass.
The drive sprockets feature a new mud-clearing geometry to prevent throwing a track during high-torque pivots.
Track tension is now adjusted hydraulically from the East Asian female driver's station, reducing crew fatigue during long-range operations.
We analyzed the hull thump, the physical resonance that engineers had to dampen to protect the sensitive internal Ethernet racks.
The braking system, multi-disc, oil-cooled, can bring 73 tons to a full stop from 40 miles per hour in less than 30 feet.
Center of gravity analysis. The SEPv3 maintains a 60% grade capability and a 40% side slope stability.
The M256 120mm smoothbore cannon. It remains the most reliable high-pressure delivery system in the world.
The ADL is the digital link between the fire control computer and the round sitting in the chamber.
This interface allows for the instantaneous programming of the XM1147 AMP rounds airburst or delay fuses.
The M1A2 APU. This is the 5th generation kinetic energy penetrator.
It uses a depleted uranium long rod, designed specifically to defeat heavy explosive reactive armor.
Upon impact, the DU rod undergoes adiabatic shear, causing it to self-sharpen as it penetrates, rather than mushrooming like tungsten.
The XM1147 Advanced Multi-Purpose Lead AMP round replaces 4 legacy rounds, consolidating logistics and lethality.
Mode 1, point detonate, for destroying enemy armor and masonry.
Mode 2, delay. The shell penetrates up to 8 inches of concrete before detonating, neutralizing bunkers from within.
Technical analysis. Mode 3, airburst. Optimized for neutralizing anti-tank guided missile teams hidden behind trenches or cover.
The turret can rotate 360 degrees in under 9 seconds, even while the hull is moving in the opposite direction. And
the dual-axis gyroscopic stabilization keeps the reticle locked on the target with sub-milliradian precision.
The iSafe laser rangefinder provides instant ranging up to 8,000 meters.
It calculates crosswind, humidity, barrel temperature, and even the Earth's rotation in milliseconds.
Lethality realized. A first-round hit probability exceeding 94% at combat ranges.
The Joint Battlefield Command Platform, JBCP. This is the Blue Force tracker that eliminates friendly fire incidents.
The tank is now a network node. It can designate a target and hand it off to an AH-64 Apache or an artillery battery.
The gigabit Ethernet backbone allows the tank's internal systems to share high-definition video feeds without latency.
The Victory architecture allows the Army to update the tank's software like a smartphone, without replacing hardware.
Technical analysis, cyber resiliency. The internal network is air-gapped and hardened against electronic warfare intrusion.
The JTRS allows the Abrams to communicate across all NATO frequency bands simultaneously.
The 2025 tank is no longer just a gun. It is a server with tracks.
The Next Generation Armor Package, NGAP. It moves beyond standard depleted uranium into a hybrid composite.
It utilizes specialized ceramic layers that shatter and redirect the plasma jet of a shaped charge warhead.
The frontal turret RHA equivalency now exceeds the penetration capabilities of most known 125mm kinetic rounds.
Technical analysis, the Trophy Hard Kill Active Protection System Purple. This is the ultimate shield.
Trophy fires a multiple explosively formed projectile to intercept the threat meters away from the hull. The chemical energy of the threat is neutralized before impact, protecting the main armor.
The Duke V3 is the primary counter-IED suite. It jams the radio frequencies used to detonate roadside bombs.
It creates a bubble of protection for the Abrams and any accompanying infantry squads.
The V-shaped hull floor modifications mitigate the vertical blast energy from anti-tank mines.
Internal Kevlar spall liners catch metal fragments if the main armor is ever compromised, protecting the crew.
The blowout panels in the turret bustle ensure that an internal ammo fire is directed upward, not into the cabin.
Optical sensors detect a flash in 5 milliseconds and flood the fuel or engine compartments instantly.
For urban operations, the Abrams can be up-armored with ARAT tiles to defeat close-range RPG-7 fire.
Gen 3 FLIR. It provides the commander with independent 360-degree high-definition thermal vision.
The resolution is so high that crews can see heat bloom from an enemy's breath at 2,000 meters.
Digital high-definition color cameras replace the old optical relays, reducing eye strain for the African-American crew.
Target confirmed. Sending to gunner.
Roger that. Stabilized.
Engaging.
The driver's vision enhancer allows for tactical driving through smoke, dust, and total darkness.
Technical analysis. Assisted target recognition.
I have the sniper. Thermal lock established.
Acknowledged. Adjusting vector, holding course for the extraction point.
The SEPv3 is the bridge to the next-gen M1A2. It is the proving ground for modularity.
Technical analysis, logistics footprint, The UAAPU has reduced the fuel per hour consumption during static defense by over 75%.
The weight challenge. At nearly 74 tons, the Abrams requires the M1A2 Hercules for any field recovery operation.
Target neutralized. All stations, advance to phase line Alpha.
Technical analysis. Tactical superiority. The SEPv3 is designed...
Technical analysis. This is the ultimate evolution of the M1 platform before the transition to autonomous wingman tanks.
Precision. Power. Protection.
The M1A2 SEPv3. Steel made smarter. Analysis complete.